Hi, Mom and everyone. I'm Janelle Villanueva Lavinia, second year AV English. Today, I'm going to report about introduction, methods, and findings. What is introduction? An introduction refers to a beginning, maybe presenting someone new to a group or inserting a new idea into a project. The noun introduction comes from the Latin verb introduce, meaning to lead in. This leading in might be the formal introduction of a speaker or the speaker's own introduction to his remarks. Balota, 1990, called the point in time when a person has recognized a word but not yet had access to its meaning. The magic moment in models. With a magic moment, a word's meaning can only be accessed after it has been recognized. Johnson Laird, 1975, proposed that the depth of lexical access may vary. He noted that sometimes we retrieve hardly any information for a word. Gary 1986, extended this idea, arguing that there are different modes of lexical access in different contexts. It is an intuitively appealing idea, fitting with our introspection that sometimes when we read, we are getting very little sense from what we are reading. Or this the processing of spoken language has a great deal in common with the processing of visual language. One important difference is that the speech signal is only available for a short time, whereas under normal conditions the written word is available for as long as the reader needs it. For example, facilitation of recognition by words related in meaning is found in both studies of spoken and of visual word recognition. Selecting that the appropriate meaning of an ambiguous word is a problem for both spoken and visual word recognition. The great majority of human beings are spoken language and have done so for a very long time, but literacy is a relatively recent development. There has been a great deal of research on visual word recognition in part because of the convenience. Appreciate how word recognition is related it to other cognitive process. Know that recognizing a word occurs when we access and representation in the mental lexicon. Know what makes word recognition easier or more difficult. Understand the phenomenon of semantic priming and how it occurs. Know how the various tasks used to study word recognition might give different results. Appreciate that different aspects of a word meanings are accessed over a time. Know how we process morphologically complex words. Know about that serial search Locogen and IC or IAC model of a word recognition. Understand how we cope with lexical ambiguity when a word can have two meanings. Methods are the specific tools and procedure you use to collect and analyze the data. Findings: the principal outcomes of a research project, what the project suggested, revealed, or indicated. This usually refers to the total outcomes rather than the conclusion or recommendation drawn from them. Methods and findings. There are six main methods have been used to explore visual word recognition: examining eye movement, measuring naming, lexical decision and categorization times, and tachistoscopic identification. Rainer, 1981. Information from the more distal regions of the span is used to guide future eye movements. Fovea is the most sensitive part of the visual field and corresponds to the central seven characters or so of average size text, subtending the central of vision is surrounded by a paraphobia, extending 5, either side of the fixation point, where a visual activity is much less good. Beyond, this is the purpose where visual acuity is very poor. We extract most of the meaning of what we read from the foveal region. Rainer and Bertrand, 1979. This play takes the readers with a moving mast that creates a moving blind spot if the foveal region was masked. Reading was possible from the parafoveal region, just outside the fovea, but at a great reduced rate, only 12 words a minute. If both the foveal and parafoveal regions were masked, virtually no reading was possible. Participants know that there were strings of letters outside the masked portion of text could report the occasional grammatically functioned words such as and could sometimes obtain the information about the starts of words. The study of regressive eye movements, where the eye moves back to the earlier material, sometimes so briefly that we are not aware of it, provides important information about how we disambiguate ambiguous materials. There has been considerable debate as to which measure from eye movement is the most informed, active. In Hawk, 1984, Wiener, 1998. Reaction time and other measures. In the naming task, participants are visually presented with a word that they can have to name, and the naming latency is measured. Reaction time is typically in the order of 500 ms from the onset of the presentation of the word. Lexical decision task. The participants must decide whether a string of letters is a word or non-word. Is the more common visual presentation methods. The words are displayed on a computer screen or tachytoscope. There is also an auditory version of this task. For example, the participants should press one key in response to the word nurse and another key in response to the non-word morse. The experimenter measured reaction times and errors rates. Tachytoscopic identification. Participants are shown words for every short presentation times. Researchers in the past used a piece of equipment called tachytoscope. If the presentation is short enough or if the normal perceptual processes are interfered with by presenting a second stimulus very quickly after the first, we sometimes find what it is commonly known as subliminal perception. In this case, participants' behavior is affected although they are unaware that anything has been presented. Semantic categorization task requires the participants to make a decision that tops semantic process. For example, is the word apple a fruit or a vegetable? Is the object referred to by the word smaller or bigger than a chair? One of the most important ideas in a word recognition is that of priming. It involves presenting material before the word, to which is a response has to be made. One of the most common paradigms involves presenting one word prior is the target word to which a response, such as naming or lexical decision, has to be made. The first word is called the prime. The time between when the prime is first presented is onset, and the start of the target is called stimulus, onset, asynchrony, or SOA. We then observe what effect the prime has on subsequent processing. By manipulating the relation between the prime and the target. And by varying the SOA, we can learn a great deal about visual word, whole sentence, and does not even have to be linguistic. It could be a picture. Backward masking. Energy masking, a stimulus is unstructured or bursts of light. Pattern masking. Masking stimulus is structured are the random parts of letters. Affects the visual features detection level. Cause interference at the letter level. Cause visual features shortage. Makes feature identification difficult. Limits time available for processing. Interfering with identification can slow down the process of word identification by making it harder to recognize the stimulus. One way of doing this is by degrading its physical appearance. This is called stimulus degradation and can be achieved by breaking up the letters that form the word. By reducing the contrast between the word and the background, or by rotating the word to an unusual angle. Presenting another stimulus is immediately after the target interference interferes with the recognition process. This is called the backwards masking. There are two different ways of doing this. If the masking stimulus is unstructured, for example, if it's just a patch of randomly positioned black dust or just a burst of lights, then we call it energy or brightness or random noise. Masking. If the masking stimulus is structured, for example, if it comprises letters or random parts of letters, then we call it pattern masking or featuring masking. These two types of mask have very different effects. Darby 1973. An energy mask operates on the visual features detection level by causing visual feature shortage and making features identification difficult. Features must cause interference at the letter level and the limit the time available for processing. Repetition priming. The, te- the technique of facilitating recognition by repeating a word is known as repetition. Printing repetition facilitates both the accuracy of perceptual identification, Chakawi and Dallas, 1981. Lexical decision response times, Scarborough, Scartes, and Scarborough of 1977. Repetition has a surprisingly long-lasting effect. It is perhaps obvious that having just seen a word will make it easier to recognize straight away, but periods of facilitation caused by repetition have been reported over several hours or even longer. Repetition interact with frequency selector in lexical decision task repetition. Priming effects are stronger for low frequency words than for high frequency ones, an effect known as frequency attenuation. Forster and Davis 1984. Forster and Davis 1984. Forster and David also pattern masked the prime in an attempt to wipe out any possible episodic memory of the prime. So they concluded that repetition effects have two components: a very brief lexical access effect and a long-term episodic effect with only the latter sensitive to frequency. Form-based priming. It is reasonable to expect that a word like contrast should prime contract, as there is overlap between their physical forms. As they share letters, they are said to be orthographically related, and this phenomenon is sometimes known as orthographic priming or form-based priming. In fact, form-based priming is very difficult to demonstrate. Humphrey, Bisner, and Quinlan in 1988 found that form-based priming is very difficult to demonstrate and found that forming-based priming was only effective with primes masked at short SOS as so that the prime is not unconsciously perceived. Farser and Barres 1998 further showed that the task form-related primes can have an inhibitory effect, slowing down the recognition of the target. Colombo 1986. And one explanation for these findings is that visually similar words are in competition during the recognition process, so that in some circumstances similar looking words inhibit each other. Frequency, familiarity, and an age of acquisition. The frequency of a word is a very important factor in word recognition. Commonly used are easier to recognize and are responded to more quickly than less commonly used words. The frequency effect was first demonstrated in tachyscopic recognition, Huss and Solomon, 1951, but has since been demonstrated for a wide range of tasks. Well, in 1978 showed that the frequency is the single most important factor in determining the speed of responding in the lexical decision. Thus, Forster and Chambers 1973 found a frequency effect in the naming task. The effect of frequency is not just due to difference between frequent and very infrequent words, like, like year versus hermeneutic, where you would obviously expect a difference, but also between common and slightly less common words like rain versus paddle. It is therefore essential to control for frequency psycholinguistic experiments, ensuring that different conditions are matched. There are a number of norms or frequency counts available. Coursera and Frances in 1967. See also Frances and Coursera in 1982 is one of the most popular of these, listing the occurrence per million of a large number of words in many samples of printed language. Length effects. Goff 1972 argued that the letters are taken out of short-term visual buffer one by one at the rate of 15 ms per liter. The transfer rate is slower to poor readers. Therefore, it would not be at all surprising if long words were harder to identify than short words. However, a length effect that is independent of frequency has proved surprisingly elusive. One complication is that there are three different ways of measuring word length: how many letters there are in a word, how many syllables, and how long it takes you to say the words. Here, the length of words can be measured by numbers of letters, numbers of syllables, how long it takes to say the words, and number of phonemes. Neighborhood effects. Some words have a large number of other words that look like mine, husband, line, main, among others, whereas other words or similar frequency have few that look them. Coulthard, Divler, Janison, and Bister, 1977, defined that n statistic the number of words that can be created by changing one letter of a target word. Hence, mine has a large N, 29. It is said to have many orthographic neighbors or fine main mire, but much has a low N5 and few neighbors. The word bank has an N value of 20, but abhorrence only has a high has an N value of 1. The related word is abhorrency. Word non-word differences. Words are generally responded to faster than non-words. Less plausible non-words are rejected faster than more plausible non-words. Coulthard et al. 1977. Other factors that affect word recognition. The S of visual words of recognition is affected by a number of variables, most of which have similar effects on spoken words of recognition. There are other that should be mentioned, including grammatical category to which word belongs. West and Sanovic, 1986. The stroke effects are black-gray. Types of semantic presenting. Priming by associate is called associative priming. The two associates might or might mean not be semantically related. Non-associative semantically related words are those that still have a relation in forms of meaning to the target, but that are not produced as associates. Consider the words dance and skate. They are clearly related in meaning, but skate is rarely produced as an associative of dance. Bread and cake are an example of another pair of semantically related but unassociated words. Superordinate category names, animals, and category instance, like facts, are clearly semantically related but are not always strongly associated. Members of the same category are fox and camel are both animals, are clearly related, but are not always associated. Priming by words that are semantically but not associatively related is called non-associative semantic priming. So the studies of semantic priming have looked at word pairs that are both associatively and semantically related. Types of priming automatic. The evidence for automatic associative priming is fairly clear-cut, and most of the research effort has focused on the question of whether or not we can find automatic non-associative semantic priming. Many early studies found no evidence of automatic pure semantic facilitation. Lopker, 1984, found virtually no semantic priming of non-associated words in naming tasks. The word pairs were related in his 168 The Psychology of Language experiment by virtue of being members of the same semantic category, but were not commonly associated, like sheep and car are related by virtue of both being types of vehicles, but are not associated. Shelton. Shelton and Martin in 1992 showed that the automatic priming is obtained only for associatively related word pairs in a lexicalization test and not for words that are semantically related but not associated. The end. Thank you for the time and God bless.